This is using the INA226 power meter with Bus Pirate. So I've got the system power unpowered, and what I have is I have my Bus Pirate, and this is an I2C device, so I have this little alligator clip thing here, and I have ground, SDA hooked up to SDA, SLC hooked up to SLC. I got them labeled. My A0 and A1 addresses are 0 here, and I've got my power external. This is just supplying supplying power to the load. Here's my load is a series of power resistors. This, when powered on, will drive current out of the positive terminal. It'll then go to this 0.02 ohm power resistor, go through that. The black wire comes out of here, and then goes through the string of power resistors, and then terminates at this supply. This is just a 5-volt supply for the INA226. And so now let me plug my power supply in here. And I'll also plug the Bus Pirate in via USB to my PC. Okay. So now on this display, you can see the input is 24 volts. I have V set to 5 volts, and I've got my I set max to 2 amps. So if I want to change this from 5 volts, I'd hit set, and the V set has an underscore under it. Then I push this button in, push it in again. You can see that the underline goes underneath the digits. So right now we're in the ones digit, and I'll go up to 7 volts, back down to 5 volts. And when I turn this on, you'll see that this draws 200 milliamps. So that's going to provide data for the power meter. You can see that. Let's put the Bus Pirate up here. There's only one LED right now. And when we turn the pull-ups on and turn the power on, more LEDs will come up. So let's go over to real term. And right now you can see these are all blinking, so that means that nothing's hooked up. So I'll go to port, and let's see, 115, 200. Mine's on port 4, and 8 and 1. So I'll go close, open, and I should be able to go question mark and get data. I do have the display set up without half duplex, so I don't get twice the amount of data. So that's what port is. Just want to give you a chance to look at it. Display you've seen. Now send. I've conveniently set up this command, which reads 2 bytes in this send ASCII. Now back up to this window. You can see that it's high impedance mode right now. So to get it into I2C, we go mode, and then we go 4 is I2C. 3, I just happen to be using it at 100 kilohertz. Depends on the application. 3. So now it's ready. We have to turn the Bus Pirate on. I do a capital W for that. And it says power supplies are on. Then I have to turn the pull-ups on, capital P. Turn that on. You can see the LEDs on the Bus Pirate there's now 3 LEDs on there. And we're ready to roll. From the data sheet, I know that my slave address for the INA226 is ground and ground. So the slave address is 8 something. If I'm writing, it's 80. If I'm reading, it's 81. You notice here there's only 7 bits. And so the last bit over here next to the one that's blue is the read or write bit. So we know that we'll have 80 or 81 as our slave address. Now let's go down to this page. And here is all of the addresses that we can communicate, all the registers that we can communicate with. So what we can do for a quick test here is look at the manufacturing ID register, and that should be 5449 if we engage the 226 properly. So now with Bus Pirate, we go back, we say start bit. In hex we go 80 because we're writing to it. Now we need to say which register we're writing to. Which register is it? This is the FE register. So we go. And then I'm not quite sure. I didn't bother to figure out if I really need to have those dummy bytes there, but I hit stop bit and we write to it, and so that means that the pointer inside of the INA226 is set up to the address FE. Now we just read our 2 bytes out of there and we go start bit. Now we, instead of doing 80, we do an 81 because that last bit now is a write bit instead of is a read bit instead of a write bit. And then I do a read and do a stop bit. And if everything's good, we should see a 5449. And we do see a 5449. I'm not quite sure why I get this knack. Just maybe I can figure it out later. So just for the fun of it, we can say is the die ID correct? So I'd go start bit. I want to do a write. So that's 0. It's 0 bar, so it's an 80. Now which register? I'm going to go to the FF register. And again, not quite sure if I need these, and then a stop bit. And now I'll use this and say send ASCII 81, read 2 bytes at address FF, and we should get a 2260. And we get a 2260. So it's working. Now we do have to set up 3 registers. That was in the EVM software. There's some really nice software, and this is the way I set it up. Was you can see the addresses are set to 0 and 0. This is the mode, shunt and bus, conversion times, and then current LSB, and then I have a 20 milliohm resistor. I'm saying my max current's going to be 15 milliamps, and then this least significant bit for the current is 100 microamps. And then what happens with the alert pin. So I set that all up. I said write, and then this is the calculation that the 226 does internally to generate values. And then we get, really conveniently, we get these values for config and calibration and mask. So if you have any questions, you hit help with registers, and then a Word document pops open and it helps you with all these registers. Pretty slick. So here's the values I'm going to use. I'm going to config a 4127 and calibrate to an 0A00 and then a mask of a 0408. And we can read it. So let's do that now. I do like using this because I have less of a chance of making mistakes here. So I can say I'm going to send to address 0 a 4127, and let's make sure that's right. A 4127 is indeed right. So I'll send that to the device, and you can see I got all ACKs, and then why don't I read it back? 4127. So that's good. So now we can go for the calibration register. We're going to say write to address 5 and OA00. So I'll send that, and then I'll check it, and I get a 0A00. And now let's do the mask, and that's to address 6. And go 0408, send, read, and we get that back. So now we've got everything all set up. Now we're ready to read voltages and powers and currents and all that stuff. So let's go back to this sheet and see what voltage is. Bus voltage register, so that's O2. So now if I go if I say set the pointer at 02, and I'll set these to blank, and now send it. Okay, so now we're pointing at 2, so it should be reading the voltage, and let's see what we get for voltage. Okay, right now we're getting 0 because it's nothing is the power turned on. V out is 0, so I turn it on. So now we have 5 volts at 200 milliamps. So now let's see what happens when I read. I get a 0 FBA, and I should, since it's probably pretty stable, I should get pretty close to that value. You can see every time I hit send ASCII, it doesn't bounce around much. So now let me turn the voltage up because we're reading the voltage. Let's see, let's turn it up to like, is it going to go up? Let's go back to there. Something seems to be a little wrong with this this power V set. There we go. Something seems to be wrong with the encoder. There's 7, so now we're 7 volt at 270 milliamps. So now it should go up. And you can see 1, 5, F4, F2, F4, F3. So now let's go back down to 5 and see if it stays the same. Goes back to the original value. Let's read. So 0 FBA, 0 FB9, BA. So it's back down to the 5 volt region. If we wanted to read currents, we'd simply read the 04 register, and the power register would be 03. So that's how to use the bus pirate with the INA226.